To understand Spark architecture better, let's go ahead and set up multi-node cluster. To set up multi-node cluster, you can actually get into your Databricks platform. Then you should be able to go to compute here. As part of the compute, you will see the option to create the cluster. You can click on create cluster. Then you should be able to specify the name to the cluster. Let's say Spark architecture. This is the name which I would like to give the name to this cluster. Now we should be able to leverage any of the LTS that is latest. In this case, I'm actually using 9.1 LTS. That is good enough. Also, it is good enough to choose standard. You don't need to worry too much about ML here. Now, when it comes to terminating the cluster, I would like to change it to 15 minutes. So if I'm idle for 15 minutes, the cluster will be terminated. With respect to the worker type, I'll be using a minimum workers as 2, maximum workers as 8. Let me actually use 3, then 4 here. So minimum is 3, maximum is 4. When it comes to driver type, it is same as worker. Now it will actually take care of setting up 3-node cluster by default. However, depending upon the workload, it might end up scaling up to 4 nodes. Each node will have 14 GB memory and 4 cores, which means 3 times 14 is nothing but 42 GB memory, and 3 times 4, which is nothing but 12 cores from the perspective of the CPUs. When it actually scales up, you will end up having 56 GB of memory and 16 cores. Now we should be able to click on create cluster. It will take care of creating the cluster for us. We need to wait until the cluster is created. Then we should be able to go to Spark cluster UI with respect to master, and we should be able to understand how the cluster is set up. Let's wait until the cluster is set up. Then we'll actually take it further as part of the next lecture. Before going to the details related to Spark architecture, let's review important UIs. They are nothing but Spark UI and Spark cluster UI master. You can click on this and you should be able to review some important details here. When it comes to Spark, it has several execution modes. They are nothing but standalone, yarn, mesos, and Kubernetes. Also, we have local. Typically, we use local for the development purpose. In production, either we use standalone or yarn or mesos or Kubernetes. The most popular one is yarn, but with respect to Databricks platforms, we typically use standalone cluster mode. When it comes to standalone cluster mode, as part of the master URL, you will be having Spark protocol like this, then IP address of the node on which master is running, then the port number on which the master is running. So this page actually gives us the details about Spark master with respect to standalone cluster to run Spark applications. When it comes to alive workers, it is nothing but 3. It is because when we actually set up the cluster, we have configured 3 as minimum workers. As there is no load at this time, it is actually using minimum configuration. That's why we are seeing 3 with respect to alive workers. When it comes to cores in use, it is 12 in total because we have 3 workers. Each worker have 4 cores, and hence we are seeing 12 here. When it comes to memory, we have 3 nodes. It is saying 26.7 GB total and 21.3 GB used. Each node in the cluster is set up using 14 GB memory. As we have 3 nodes, it is nothing but 42 GB memory. However, when it comes to the memory that is being used by the Spark, it is only close to 27 GB. So out of 42 GB, only 27 GB is provided to the Spark. As we have reached the threshold of 15 minutes, it got terminated. I need to make sure that the cluster is started again to actually go to the details about the Spark cluster UI master. Let's wait until it is up and running. We will actually resume with respect to the details related to Spark cluster UI master, and then we'll take it further. Now the cluster is up and running. As of now, there is one application which is running. The application is nothing but Databricks shell. I haven't started it. I don't know how it is started. I need to troubleshoot, but don't worry too much about it at this time. The reason why we are actually seeing 12 used as part of course in use is because of this application. It is using all the 12 cores. When it comes to memory per executor, it is nothing but 7.284 GB. When you add this 7.284 GB times 3, because we have 3 executors, it will actually come to 21.3 GB. That's why you are seeing 21.3 GB here. This is how you should be able to review the Spark cluster UI master and understand the cluster capacity at any point in time. Another important UI is nothing but Spark UI. In this, you have a navbar. As part of the navbar, you have jobs, stages, storage, environment, executors, SQL, so on and so forth. To understand the architecture, the 2 important tabs in this navbar are nothing but executors. You can see all the executor details here. You can see there are 4 executors. One of them is nothing but driver, and then we have 3 of them from workers. You can also review the details about course at each executor level. For all those executors which are categorized as workers, there are 4 cores in this cluster. That's why total we have 12 cores for this cluster. On top of executors, to understand the overall capacity of the cluster, the other important section to go to the details with respect to Spark architecture quite often is nothing but environment. This page will actually contain all the details with respect to properties which actually controls the runtime behavior of the Spark application. In the perspective of reviewing the architecture details, we might have to come to this page to review certain property values. Also, we should be able to use spark.conf.get to actually get a particular property value. However, this will actually give us a consolidated view, and we should be able to search for particular keywords to actually get values for relevant properties. These two are the most important pages from the perspective of understanding the architecture. However, when we actually go through the details with respect to Spark architecture, we might review other pages also. One of the key thing is when we actually get into adaptive query execution, we'll be reviewing some of the properties here. Those properties are nothing but spark.sql.adaptive.enabled, spark.sql.shuffle.partitions, so on and so forth. We can also review the properties such as spark.sql.auto broadcast join threshold and other important properties as well from this page. This page is very, very important, not only from the certification perspective to understand the architecture, but also when it comes to troubleshooting certain issues with respect to projects, we need to get into environment so that we can review the properties and understand why the cluster is behaving in a particular manner, or why a particular application which is submitted as part of the cluster is behaving in a particular manner. As part of this lecture, let's go to the details about executors and slots. It is very, very important for you to understand these terms: executors, slots, and also you need to understand the relationship between slots and cores, and also eventually we should be understanding the details with respect to tasks. That being said, at this time we have a 3-node cluster along with the driver using a Databricks platform. You can actually see the details here. If you actually go to the configuration, you can see that we have 3 minimum workers. You can also go to Spark cluster UI master. You should be able to review the details with respect to workers. We have 3 workers. Each worker have 4 cores. So if you relate to this picture, we have 1 driver and we have 3 executors. As part of the each of the executor, we have 4 cores. When no data is being processed, a core is nothing but a slot. So in this case, we have 4 slots on each of the executor in the cluster. So total capacity with respect to total slots is nothing but 12. Once we submit the Spark application to process the data, driver will actually determine which slots should be used based upon certain criteria, and then it will actually allocate tasks to empty slots. If slots are busy with some other tasks, then driver will not actually use those slots. A slot will convert into task as soon as data is being processed by that slot. So slots represent empty cores which are not actually processing the data. At the beginning, when no jobs are run as part of this cluster, we have 3 executors. Each executor have 4 cores, which means each executor have 4 slots. That means we have capacity of 12 cores or 12 slots. Once we start submitting the application, those 12 slots will be converted to 12 tasks, and tasks are the ones which actually process the data. As part of this sectional module, we are actually going through the details with respect to Spark architecture. In this lecture, let's go through details with respect to submitting the applications, and also we'll understand what happens when we actually submit the application. Before submitting the application, let's review the current status of the cluster. The cluster is up and running. You can see here. You can also go to Spark cluster UI master, and you should be able to see the current available capacity. As of now, all the cores in use. They are in use with respect to this application which is related to Databricks shell. We will see what happens when all the cores are busy serving this one. Now let me actually go to the notebook. Now let me say df equal to spark.read.json. I have data in this location in the JSON format. It is nothing but public retail_db_json, then orders. Now let me run this. You should be able to expand and see what is happening. You can see that it have submitted a job in the cluster. You should be able to click on this, and you should be able to review the UI from here also. This UI is same as what we have seen with respect to Spark UI in the past. I will go to that in a moment. You will understand what I am talking about here. Now let me close this for now. Now let me say df.count. Let me run this. You can see that we got the count for this data frame. You should be able to expand this You can see jobs associated with this. There are 2 jobs. One is job 1, second one is job 2. Once again, if you click on this, it will take you to this Spark UI specific to this job and its stage. Now you can actually close this. You can go to the compute and then go to the cluster. If you go to the Spark UI, you can see 0, 1 and 2. These are the job IDs which we have seen earlier. We can actually go to the notebooks here. We can click on this. We should be able to expand and we should be able to see the job IDs. These job IDs and whatever job IDs we are seeing as part of the previous page are same. Let me hit back here. Let me go to Spark UI. Whatever job IDs you are seeing here are same as what we have seen as part of the notebook. Now you can go to the executors. As part of the executors, you can see that total 5 tasks are submitted so far. All of them are completed. We'll come back to this at a later point in time. Now let's go back here and understand what happened. Before running that spark.read.json, there were no applications running as part of the cluster, which means all the capacity is available as slots. As we have 3-node cluster, it means we have 3 executors. Each executor have 4 slots because we have 4 cores on each node of the cluster. The overall number of slots that are available as part of the cluster is 12 before we actually ran that command called as spark.read.json to read the data in JSON files into the data frame. We have processed a very small dataset. It might use 1 or 2 tasks to process the data. When it requires those 2 tasks, when the application is submitted, it will actually pick the 2 available slots in the cluster and then it will actually process the data. Once the processing is done, then they will be converted back to slots. They will be made available for future applications. Sometimes our data processing logic might require the capacity which is greater than the overall capacity of the cluster. In this case, it is nothing but 12 slots. However, to process the data, we might have to use 80 tasks. In that case, at any point in time, only 12 tasks will be processing the data. As the tasks are completed, they will be given back as slots. Once they are made available as slots, the remaining tasks which are supposed to be executed will take over those slots and they will use those slots as tasks and continuously it will take care of processing the data. That's how it works when it comes to the applications which require a lot more capacity than the available capacity in the cluster. As part of our cluster, we have only 12 slots. However, even if our data processing logic requires more than those many tasks to process the data, still it will work without any issues. Let's look at it with an example so that you understand what I'm talking about here. As part of this lecture, let's go to the details related to running Spark application to understand the execution lifecycle. You should be able to run these cells. You can see that there is a location which is provided by the Databricks itself. Databricks actually provides several public datasets. One of them is nothing but airlines. As long as it is not blocked by your company, you should be able to access these files. Now I'm actually trying to read the files in this location and creating the data frame. As part of this location, we have CSV files and hence I'm using spark.read.csv. I'm setting header to true so that I should be able to determine the names of the columns based on the header in each and every file. You can see that the dataset have quite a few fields. Now let me run this to create an object by name username so that I can dynamically determine the logged in user. Let me run this to actually delete the folder if it already exists. I'll be using this location to write the output into it. Now let me actually run this. This will take care of reading the data from this location. And then it will group the data by year, month and day of month. Then it will actually perform the count. The final output will be returned to this location in the form of Parquet files. You should be able to expand this to see what is going on internally. You can see that this piece of code is being run as multiple jobs. As part of the first job, it typically determines the files details. As part of the second job, it actually processes the data. To process the data, it requires 25 tasks. However, the overall capacity of the cluster is only 12. You can actually review the details by going to compute. Then you should be able to go to the cluster here. You can see that when it comes to the cluster, it have only 3 executors, which means it have only 3 workers. Each worker have only 4 cores, which means the overall capacity of the cluster is only 12. However, it requires 25 tasks to actually process the data. To provide those 25 tasks, it will actually make sure that data is being processed in rolling fashion. First, it will use the 12 slots that are available to process the data. As the 12 tasks which are assigned to those 12 slots are being completed, the new tasks will be added to the emptied slots and then it will slowly complete the all the tasks to actually process the data. That is what is going to happen when you have to process the data, which require a lot more capacity than your overall cluster capacity. You need to keep these nuances in your mind. That being said, when it comes to the cluster, you have executors. As part of the executors, you have cores. When the cluster is idle, then you will be having empty slots. You can see the empty slots here. As data is being processed using tasks, these empty slots will be filled using tasks. You can actually submit the jobs which require more number of tasks than the empty slots. In that scenario, it will actually process the data in rolling fashion, which means it will take care of submitting the job with a possible number of tasks. As those tasks are being completed, new tasks will be created as slots are being available when existing tasks are being completed. That is how it will take care of processing the data when it requires more number of tasks than the available capacity. Keep in mind that it is very important for you to understand all these nuances related to Spark architecture to take the Databricks certification exam effectively. You should be familiar about driver, executors, tasks, slots, so and so forth. Make sure you spend some time in understanding all these nuances so that you can actually give the certification exam with confidence. I will try to cover quite a few other important concepts also as I get the feedback from the students. But for now, this is more than enough to get into the details with respect to Spark architecture. However, in this sectional module, we will also cover details with respect to adaptive execution. There might be few questions with respect to adaptive execution. Be prepared with respect to adaptive execution as well. You will understand details related to adaptive execution, which is also in the scope of the exam as part of subsequent lectures in the sectional module. As part of this lecture, let's review properties related to Spark adaptive execution. When it comes to Databricks notebook, it exposes an object called as Spark. The type of Spark is nothing but Spark session. You can also use type and you should be able to pass Spark to it. You will see pyspark.sql.spark session. When it comes to objects of type Spark session such as Spark, they expose an attribute called as conf. The conf is of type runtime config. Runtime config is a class under pyspark.sql.conf. Runtime config objects actually exposes a couple of functions. They are nothing but get and set. Get is primarily used to get the value for a given property. Set is primarily used to override the existing property. So in this case, you should be able to get value related to spark.master using spark.conf.get like this. You can see the master URI based on Spark standalone cluster. It is because the clusters that are created using Databricks Platform uses something called as Spark standalone. That being said, when you actually attempt to override important properties like this, it will not affect the existing session. Even though there are no errors with respect to this piece of code, it is useless. It will not change the behavior of the cluster to local. Still, it will be running using Spark standalone only. So some of the properties, even though when we use set like this, even though we don't see any errors, they will be ineffective. We will not be able to override those properties. That being said, now let's go to the details related to important properties associated with adaptive execution. The most important property is nothing but spark.sql.adaptive.enabled. You should be able to say spark.conf.get like this, and you should be able to pass the property name like this. You can see that it have returned true, which means adaptive execution is enabled by default as part of this cluster. In the latest versions of Spark, adaptive execution is actually enabled by default. On top of this property, there are quite a few properties related to adaptive execution which contain adaptive in them, but they are not very important. However, we should review this very important property called as spark.sql.shuffle.partitions. By default, it is set to 200. However, it is ineffective when adaptive execution is enabled. When adaptive execution is disabled, then it have its significance. We will go to those details as part of subsequent lectures in the sectional module. That being said, these two are the important properties which you should review when it comes to Spark adaptive execution. Let's perform few tasks and understand all the nuances with respect to adaptive execution and also details with respect to shuffle partitions. As part of this lecture, let's understand how to disable adaptive execution and run Spark application. We'll actually go to the details about the application that is submitted as part of the next lecture. When it comes to validating whether adaptive execution is enabled or not, we should be able to use this piece of code. You can see I have already validated. It is enabled by default. Also, when it comes to Spark SQL shuffle partitions, it is 200. Now, when it comes to Databricks Platform, it actually provides a lot of public datasets. Unless and until your company blocks, you should be able to access those files and you should be able to validate the platform the way you wanted to validate. In this location, which is provided by Databricks Platform, there are 22 files. The overall size of these files is more than 10 GB. We'll be using this dataset to explore what happens when we run application by disabling adaptive execution. That being said, this is the piece of code which will actually create the data frame using the header of these files as column names. You can invoke something called as RDD. It is nothing but an attribute that is available on top of the data frame. It exposes a function called as getNumPartitions. We should be able to get the number of partitions. In this case, for this dataset, the number of partitions is 93. Now, you can also print the schema. You can see the columns that are there as part of this data frame. We'll be using year, month, day of month to group the data by those 3 columns so that we perform grouped aggregation operation before writing to the target location. As grouping results in shuffling, shuffle partitions comes into picture. Otherwise, shuffle partitions doesn't comes into picture. It will be easier for us to even review adaptive execution details when we actually perform those operations which involve shuffling. That being said, here we are actually creating an object by name username. It will be logged in user. If this target location exists, we are trying to delete. This is the location into which we will be writing the processed data. If the folder exists, it will be deleted. Now, this is how we should be able to disable adaptive execution. You can see here. We just have to say false here. It will take care of disabling the adaptive execution. You can also pass the false as a string. So instead of passing Boolean value, you can also pass as a string. Even using a string approach, we should be able to disable adaptive execution. We just have to set this property to either false as Boolean or false using string type. Now, this is the piece of code which actually reads the data from this location, then groups by year, month and day of month, then performs the count and writes the output to the target location. When it comes to the output here, the most important thing which you need to review is nothing but with respect to the second job, the second stage, which is nothing but this one. You see 200 here. The reason why it is using 200 is because with respect to Spark SQL shuffle partitions, the default value is 200. And also midway through, we have disabled the adaptive execution. When adaptive execution is disabled, it will use spark.sql.shuffle partitions, which will determine the number of partitions that are supposed to be used when shuffle is involved. In this case, because of group by and count, shuffling is involved. For that reason, we are seeing 200 here. We'll be going to the detailed review as part of next lecture. You will understand quite a few other details as well. But for now, keep in mind that this 200 is coming from what we have seen with respect to Spark SQL shuffle partitions. You can also review the location. This target location have many files. You can see the size of these files. They are very small files. They are not very big files. Yes, we are able to disable the adaptive execution and run Spark application. Now, as part of the next lecture, let's perform detailed review with respect to this application. Then we'll actually go to the details about running Spark application using adaptive execution. We'll also see how many partitions will be used when it comes to shuffling when adaptive execution is enabled. As part of the previous lecture, we have gone through the details about disabling the adaptive execution and then running the Spark application. In this lecture, let's review the details of the jobs that are executed to process the data without adaptive execution. First, let's review the input files. For that, I have actually created an object by name username and then built data frame by name df using the target location which is specified as part of the Spark application execution in the last lecture. Once the data frame is created, it exposes a function called as input files. Using that function, we should be able to review the files. In this case, df.inputFiles actually returns a list of files. I'm using len on top of it. You can see that it contains 200 elements. You can also review the details by saying df.inputFiles like this. You can see all the 200 files here. They are very small files. You can also use %fsls and you should be able to specify this path, or you should be able to specify the path using dbutils.fs.ls. So let me say dbutils.fs.ls. Then let's specify the path and run it. We can see the details of all the files. You can see all the files are very small in size, which means using default Spark SQL shuffle partitions after disabling the adaptive execution is overkill. We end up having too many small files, and also using 200 partitions for shuffling is overkill. It will take more time to actually process the data and more resources to process the data. Either we have to reduce the number of shuffle partitions and then run again, but we don't know what is the exact number we should be using. When it comes to adaptive execution, what it does is, before actually performing shuffling, it will actually see how much data is being filtered out, how much data is being pre-aggregated. Based upon certain metrics, it will determine how many partitions should be used for shuffling. Once we enable adaptive execution and run Spark application, we can review those details. But before going through those details, let's go to the cluster here. Then let's go to the Spark UI. Now, before reviewing the jobs here, let's go to the notebook which we have ran. It is nothing but this one. Let's scroll down. Let's expand this. The job IDs are nothing but 15 and 16. Let me go to the compute. Let me go to the cluster. Let me go to the Spark UI. Let's review the details with respect to 15 and 16. You can actually click on 15 to see what have happened, and also we can click on 16 to see what have happened. When it comes to job ID 15, it contains only one stage. Also, it took only 0.6 seconds. You should be able to see the details about stages here. There is only one stage with respect to job 15. You can also click on this to see what have happened in that stage. Most likely it would have listed the files in this location and got the metadata. Now let's go to the other job. The other job is nothing but the job with ID 16. It took 37 seconds and also it contained 2 stages. Now we should be able to click on this and then we should be able to review the details about what have happened in each stage. As part of the first stage, it have actually performed the reading of data and processing. As part of the second stage, it have actually written the data to the target. In between, it took care of shuffling. As shuffling is involved, it actually created 200 tasks based on Spark SQL shuffle partitions, and then using those 200 threads, it have actually processed the data. When it comes to amount of data that is processed by these 200 threads, it is only 558.5 KB. A very small dataset, but it have used too many resources for that. When it comes to output, the output is only 330 KB. For 330 KB, using 200 threads is significant overkill. Also, because of 200 here, we are seeing 200 files in the target location. All the files are small in size. We have already reviewed those details. Let's go back into that notebook, which is nothing but this one. You can see there are 200 small files in that location. You should be able to get the sizes by using dbutils.fs.ls. If you are using Databricks Platform, you can see all the files are less than 2 KB. This is how you should be able to review the details and determine the side effects of disabling the adaptive execution and using the default value with respect to Spark SQL shuffle partitions. For this workload, we should be using 1 or 2 with respect to Spark SQL shuffle partitions, not more than that. However, it will be nightmare for us to determine Spark SQL shuffle partitions whenever shuffling is involved. That's where adaptive execution comes handy. Let's go to the details about running the same application with adaptive execution being enabled, and we will see how it actually behaves with respect to processing the same workload using the same logic. As part of this lecture, let's run Spark application with adaptive execution. In this case, we are using the same notebook what we have seen earlier, where we have executed the Spark application without adaptive execution. Only thing is, the cell which actually disables the adaptive execution is removed from this notebook. Rest of the stuff is same as what we have seen earlier. As of now, the data processing is going on. You should be able to expand here and you should be able to review the details. As of now, there are 2 jobs. The first one is same as what we have seen earlier. It actually determines the sizes of the files by going to the details. If you look at the second job, you can see that it haven't determined the number of partitions that are supposed to be used for shuffling. It is still processing the data to actually read the data from the files, and then it actually groups the data by the key and performs the count that is supposed to be performed as part of the initial stage. Once this stage is done, based upon the metrics, it will determine the number of partitions that are supposed to be used for shuffling purpose. You can see that a new job is added towards the end of this job and this stage. With respect to this job, you can see that this 25 tasks are skipped because the data processing is already done. However, with respect to the tasks that are related to the shuffling, there is only one task. It is because we have enabled the adaptive execution. Based upon the metrics, it have determined that it is enough to have one task to actually take care of shuffling instead of 200, which is default if adaptive execution is disabled. You can also validate number of files by running this. You can see that there is only one file. It is because there is only one partition with respect to shuffling. As there is only one partition, only one file is created. This process of clubbing too many small files into one small file is called as coalescing. When it comes to adaptive execution, it takes care of coalescing by default based upon the metrics of the prior stages. That being said, let's go through the Spark UI and review the jobs related to this execution. The job IDs related to this execution are nothing but 25, 26 and 27. Let's go to the cluster. Let's go to the Spark UI. Let's go to the details related to 25, 26 and 27. When it comes to 25, it is same as what we have seen earlier. It actually reads the files in that location and captures the details about metadata of the files. The heavyweight processing is done as part of this job. You can actually click on this to review the stages. With respect to this job also, there is only one stage. You can see here, this have actually read the data and grouped the data based on the keys and performed the count. It took a bit of more time here. However, it have used only one file to write the final output because the output is too small. That being said, now if we go to the next job, which is nothing but job with ID 27, it took only 0.4 second, and when it comes to the number of tasks that are associated with stages for this job and stage is only one. It is not 200 because adaptive execution will determine the number of partitions that are supposed to be used based upon the workload. It is very, very important for you to understand the details with respect to adaptive execution. It is quite powerful and it is introduced as part of Spark 3.x. In the latest versions, it is by default enabled. Using it, you should be able to achieve better performance, but in some cases, you might have to disable adaptive execution. You need to keep the Spark SQL shuffle partitions in mind whenever the adaptive execution is disabled. You might have to jack up the number with respect to Spark SQL shuffle partitions, or you might have to reduce as well. As part of the section module, in earlier lectures, we have gone through details with respect to Spark Adaptive Query Execution. Now, let's review some of the important properties associated with Spark Adaptive Query Execution, or AQE. You can actually go to the official documentation and review all the important properties here. There might be one or two questions on adaptive query execution. You can spend time on this and be prepared for those questions. However, the questions will not be way too complicated. They should be a bit straightforward as long as you have the core concepts related to adaptive query execution and also what all features it actually brings onto the table. The four important features that it brings onto the table are nothing but coalescing post shuffle partitions, converting sort merge join to broadcast join, converting sort merge join to shuffled hash join, optimizing skew join. We have already gone through the details with respect to coalescing post shuffle partitions earlier. The reason why it is actually coalescing the post shuffle partitions automatically when adaptive query execution is enabled is because this property is set to true. If you set it to false, it will not coalesce the shuffle partitions when we actually run the jobs which involve shuffling. For coalescing the partitions, there are quite a few other options also, but this is the most important one. On top of this, we can also convert sort merge join to broadcast join. There is only one property associated with it. It is nothing but Spark SQL adaptive auto broadcast join threshold. In this, you have to specify the size. Based on the size, it will actually confirm whether broadcast join should be used or sort merge join should be used as data is processed when application is set up. So this is the property which you need to keep in mind to convert sort merge join to broadcast join. It is nothing but Spark SQL adaptive auto broadcast join threshold. This is not true or false property. You have to set the size. If you set the size as -1, it will actually disable the conversion of sort merge join to broadcast join. Also, you can convert sort merge join to shuffled hash join. Both sort merge join as well as shuffled hash join are reduced side joins, whereas broadcast join is kind of map side join. With respect to converting sort merge join to shuffled hash join, these are the properties. Actually, there is only one. It is nothing but Spark SQL adaptive max shuffled hash join local map threshold. So this is the property which you can use to actually set to convert sort merge join to shuffled hash join. Again, this is not true or false type of property. You have to specify the size based on which the conversion of sort merge join into shuffled hash join will take place. Another important feature is nothing but optimizing skew join. First of all, you need to understand the term called as skew. If you are familiar about US geography, the West Coast have California, Washington, Oregon states, etc. Now, California is almost 70% of the West Coast, while the other two states are only 20-30% or there might be other few states also. With respect to all other states might be only 20-30%, whereas California is almost 70%. If you wanted to compute some metrics based upon state as key, then data will definitely be skewed because California have 70% of the data while rest of the states have 30%. In those scenarios, you should be able to optimize the skew by using these properties. By default, skew join is enabled with respect to adaptive query execution. If you wanted to disable, you can set it to false. You can also go to these additional properties where you can actually define how the skew join should be optimized using adaptive query execution. So these are important categories which you need to keep in mind, and also some of the important properties which you need to keep in mind from the perspective of adaptive query execution. I'll not be able to demonstrate scenarios with respect to each and every feature of this. I have already gone to the details about the most important one, which is nothing but coalescing post shuffle patterns. You should be able to spend some time and understand some of the keywords here, and then you should be able to answer the questions associated with the adaptive query execution in the certification exam.